It's time to start monitoring my solar inverter. It's all hooked up. It's connected to the Wi-Fi with a USB dongle. And I will be accessing it using MODBUS TCP, which is supported protocol for this inverter. So it's going to be really interesting to see what information we can get hold of. So finally I can start my video series on hooking up my inverter to Magic Mirror. In this case I have not finished, so I'm still working on this. You will actually be following the different steps in how I connect and use the data in the Magic Mirror. And of course the first thing is to hook up the inverter to the Wi-Fi. I have an access point quite close to the Wi-Fi adapter, so it's a small adapter put on the inverter, and it has connected, so I can grab the IP address here, which I will need. And two things here. First of all, the supplier of the inverter told me that Huawei has a problem with mixed networks with both 2.4 and 5 gigahertz Wi-Fi networks. So what I actually did was I created a second network only with 2.4 gigahertz to be safe, on the safe side, and connected the adapter to that network. So that's why it says 24 here. Secondly, I had to ask them to make a change in the setup for the Wi-Fi connector, and that was to have MODBUS TCP set to unrestricted. In that way I can connect from any IP address I want to my inverter. So those two things we prepared in the inverter. And now that I have the IP address, I want to try and access it. And I have already found the way that I want to do this. I found a Python library for my Raspberry. And it's this one. I will put a link in the description. And it specifically says it can connect to the SUN2000, which is the model I have. So I have already installed it directly on my Raspberry Pi. I'm using a Raspberry Pi 4. And then I copied the example code from here into my Visual Studio project. So that's the next thing that will happen here. So if we move into the Visual Studio Code, I'm connected to the Raspberry with the remote development. And I have actually the Magic Mirror running as well in Visual Code here to be able to debug and so on. But now I created just a small test program to start with. I've imported libraries that was in the example, and I also know that I need a async IO, and that's because it's using the await function here. So I will need to include that library. Put the IP address here, and also change the port because the default port for Modbus TCP IP is 502, so I'm using that. And then I had to modify the slave ID. It said 0 from the beginning, and I tried that first, but it didn't work. But slave ID 1 is what's going to be used in my case. So what else do we have here? I can add a lot of information, of course, and I will do that. To give you an idea, we can see what's listed here. Takes a time to load. Just to test, I'm using the active power to see how much power I'm generating. And here you can see the different messages that are available. So I think I will find a lot of useful information here. And I will decide later what I want to have. Basically, you can control, and I think you can control. I haven't tested that, and my plan is not to control it, but at least to get all the information that you need from the inverter. And then we will just print the result. And then I had to create the main down here and use the loop function to wait for the to the async function Huawei Solar that I created up here. So the main will run this and wait for the result, and then hopefully we will get some printouts. So to start with that, we will just simply execute it. Okay, I can't have that running. Let's stop the panic mirror. Go back to this one, then execute it. We have our debug here. Okay, missed off here. I messed it up. Of course. Let's run it again. It's running, and I'm getting the power here. 1.254, so it's getting darker and darker, as you can see. And I think the number of PV strings here was, yeah, it was up here. Another result there, I didn't see that. And this is really the base of it. So the next thing will be to figure out what I want and then to construct this in my Raspberry Pi. So the good thing about this is that my second plan was to use Modbus with a serial port, but now I don't have to do that. That would require me to have a Arduino communicating with that and so on, and then uploading it. But in this way, using Modbus TCP, in the same way as I have already done with my heat pump, and that's in another episode. So I really like this because it's simple and it's fast, and you can do what you want. So step one, it's at least working. So next I need to figure out what I want to measure and how I want to present the values. Before the solar array, the situation is quite simple. I have my energy meter and it tells me how much I purchase, and that's the same as my consumption. So that's quite easy. With a solar array, this situation is a bit different. I have considered two scenarios here. The first one here is an example of when I'm producing 10 kilowatts. I'm consuming directly 3 of them, and I'm sending 7 kilowatts to the grid. The energy meter in the middle here have 2 meter values, sold and purchased. And so in this case, I'm selling 7 of them. And the second scenario is when I'm not able to produce all the energy I need. This could be potentially be 0, but in this example, I'm producing 2 kilowatts and I'm consuming 4 of them. And that means that I need to buy 2 kilowatts. And then the energy meter will show a purchase value of 2 kilowatts. So these are the two different situations. So how can I measure this and where do I need to get the values from? We'll first look at the energy meter. It has 2 meter values, and it measures the current consumption, and it also accumulates both of these values. And there's 1 meter for the purchased energy and 1 for the sold energy. The solar inverter I will also need to communicate with, and that's the whole purpose of this. So besides from having a lot of other values, voltage and effect and so on, same as the energy meter, the solar inverter is telling me how much I'm producing. And this I can't really get from the energy meter, since the part which is consumed in-house will never touch the energy meter. It will just come directly from the inverter. So I need this produced value to be able to calculate what I want. The inverter has both current value and the accumulated meter values. Besides that, it also has some statistics about yearly or daily yield and top power per day and things like that. That can be interesting. And then I also want to see the consumed amount. And in this case, I actually need to calculate it, since my total consumption, my gross consumption, will be the produced minus the sold and plus the purchased kilowatts. And this I will calculate in the magic mirror. And then I also will generate statistics, both forecasts and just accumulated values for day, month, and year. So these are my values, and then I want to show this in a good way. So what I'm considering is to have it something like this. So in this example, you can see the net consumed value, and in this case it's negative, and that means that I'm actually selling 5.7 kilowatts here right now. And the gross consumption, which is what I'm consuming in-house, it's calculated, and at this example it's 0.276 kilowatt. And here you can see the total produced. So 0.276 is going to the house, and the rest is sold. And then I want to show two values here. I want to forecast my net consumption, so I know how much I will buy, basically. So this will be the value that I'm actually buying, and in the end will cost me money. And then for the production, I'm only going to show the accumulated value, since it's really hard to predict this and get a good calculation of a forecast. So this will be accumulated values for day, month, and year. I'm missing a few values here that might be interesting, but I don't want to clutter the display too much, so I will not show them to start with. I will have them in the data, and I will record them. I will also have them on my debug index page, but I will not show them to start with, at least. And that is the gross consumption. That is still interesting to know how much is I actually consuming by month or by year, including the energy that I'm producing. And then the accumulated sold would also be interesting to see how much I'm actually selling and that I will get paid for. So we will see if that fits in and we can add that. And then I also have a blue number here. This is actually quite interesting, because this is the profit. This is the calculated profit based on the sold kilowatt hours. And it's also, since the value of this is based on an hourly rate, which is shown up here, it's calculated every hour and accumulated. So this is the actual value that my profit will be. And that's, of course, nice to see. Maybe I don't need a accumulated energy then, because the profit and the energy go hand in hand here. So we'll see. But this is my thinking right now. So I guess it's time to start doing some Python coding in the Raspberry. So I open up my Visual Studio Code and connect it to the Raspberry with the Remote Explorer. And I have my demo project here, and I have started to adding some code. And the first thing is that I'm creating a class for holding the variables for the inverter, which I will start to communicate with, and also for holding the function for updating the values. So if you have a quick look at the variables, I will have the important things here is the energy, the current consumption, power meter, which is the accumulated energy. Then I also have some fault codes and monthly yield, and yeah, some interesting data from the MODBUS TCP IP, which the solar inverter is communicating with. And then I've started with the function. The first part here we can skip. This is debug code. So I can actually remove it, so it's easy to see here. And then we have the actual code here. It's an async function. I will explain a bit about that later on. But the first thing we do here is that we need to connect to the solar. And that's done here, this line. And it's a wait function for the async library. And this is according to the library for Huawei Solar. So I'm just following those code examples. And then I've also added an exception here. So if it's for some reason fails, I will set the energy to 0, and I will also clear the client pointer and also stop the client. So just to be sure, and then I will exit the function. And this has proven to work, that in different situations when it can't communicate, it will stop itself, and that works fine. So the first thing I do up here is actually check that I still have the client connection. I could potentially stop the client after each call, but since I'm updating fairly frequently, I decided to keep the client connection open and reconnect if it fails. The next part here is to retrieve the data. And here you can see that I have the code for the different values that I want to have. In this case, active power. A bit down here, you have the device status, temperatures. Then it goes on like that. And then I'm storing the values in my structure here. So I will have that available. So I have made a try and accept event for each of these, just to give it a bit more control and easier debugging. But that's all basically this function do. So in the end here, it will also note the time for the last call if successful, and that I will later use for alarms if I lose communication with the inverter for an extended period of time. So same way as I do with my other Magic Mirror libraries. The sync loop is down here. And what it basically does is that I created this one since I have several different communication ways that need to have the await function. In this case, it's the thermal heat pump and it's the solar inverter. So that's why it's constructed like this. So I will include this in my threading. It will be called every 30 seconds, and then it will loop the async functions for thermal heat pump and then for the Huawei inverter. So it's a combination of async, loop, and of threading. Then we need to initiate this. That's done at the bottom in the main. And here you can see that I have prepared some settings. So first I will initiate my class, solar, and set the IP address and the port. That's a standard MODBUS TCP IP port 502. And then I will also call my async loop here, which will in fact check both thermia and inverter. So then we need to use these values somewhere. So I will move up to my Flask web server pages. And the first one we can have a look at is the index page. For you who have seen my earlier videos, this is the debug page, which I want to have all kinds of values for debugging. So I will uncomment that. We have a lot of information from the device itself. Scroll down a bit, coming down to the wheel page. This is the root page, which is actually the data that is sent to the Magic Mirror. So here what we want to do is that we want to have this part here. This is the old value for current consumption. But this needs to be replaced because this one would only show the consumed energy. And if I'm not consuming anything, it would show 0. So I want to make the calculation that I let you know before. So we will actually comment this one out and replace it with this one. And this is the energy meter value minus the production. So this will show positive if it's consumed and negative if I'm producing. And then I also want the gross consumption here, and that is calculated from the production and from the energy meter values for sold and purchased, as you saw in the presentation. Those values I want to send to the Magic Mirror, and then I also have a few values for the solar inverter that can be good to have. So add on that. So before we try this out, we need to show it on the HTML page. And I have made an example here. First, we will have the styles here that we need. And this is the first part here is just to position the area where I want to show the solar information. And the second part here is to make a meter for showing the solar production. And then we will move down. Then we will move down a bit here. And we want to show the NED values. And in this case, I will be hiding the values if the NED is 0. And then I also want to show my meter. This. And now we should be able to test this. So we can see it's running. We can have a look at the web page. Here we can see that we are producing 8.4 kilowatts. We have a negative, meaning that we are selling 7.7, and then the gross consumption is 0.747. And then we also have the forecasts that will be quite low now because I'm producing a lot of energy myself, so it will only be the net consumption here. And then we have actually the produced values and the money that I have in profit as well. So yeah, I'm happy with that.